So our keynote speaker, we're very privileged to have Mike Card here, the Deputy Secretary General of IALA, and he's going to speak about this evolving e-navigation concept. And it's our chance to understand where IALA, which has been so influential, working very, very closely with the IMO and many other institutions and organisations, it's our chance to see how that thinking around e-navigation is developing. Mike, thank you very much indeed for coming this afternoon.
Thank you, Chairman. Your Royal Highness, distinguished guests, ladies and gentlemen. It should be my task, I think, to set the scene for this conference, and so I'm going to say a few words about the development of e-navigation, nothing too technical, and then look at where it might be going in the future, after passing through a couple of points about what is being done in regional projects and various national initiatives. IALA is an organisation which was formed in 1957 by a number of nations which wanted to work for the improvement and harmonisation of marine aids to navigation, and it's 57 years ago, 2014 now, from that 1957 date, and IALA continues to be in Paris, where its original headquarters was located, and it now has grown to membership of about 80 plus nations and 130 industrial members. Many of you participate in our work, and we're very grateful for the contribution that you make. The United Nations Organization, International Maritime Organization, has defined e-navigation like this, and the words in blue are, of course, the words in which we all place great importance: safety and security for shipping at sea. But its purpose was to enhance berth-to-berth navigation and related services, and this would be for the reason of making the mariner's task easier by the improvement of the equipment he has on board his bridge, and also by shore services provided to him from national and local organisations. But the wider picture, as your chairman has mentioned, is that the maritime portion of the journey of those goods on board the ship is just part of the total transport chain, the total picture. And so we must remember that the purpose of maritime navigation is primarily the transport of goods. It's to get the bananas from the Caribbean to your supermarket, or to take motor cars from a factory, perhaps in this country, to customers or showrooms in the United States. So all the time we must remember that the work that we're doing with e-navigation is complementing the total transport chain. I don't know whether you can see that picture. I may have broken one of the rules of PowerPoint presentations, but it's a picture I took from a NASA website about the development of the universe from the Big Bang. And I think the Big Bang with e-navigation was the development of modern electronics in about the 1960s, when we moved from having discrete transistors into having integrated circuits with tens and then dozens and then thousands of transistors on a single tiny chip of silicon. And that, I think, was the Big Bang that probably enabled us to start e-navigation. But in 1995, the American Global Positioning System came into service, and that was a major step forward, because at that time then a mariner could know his position almost anywhere in the earth, and he'd be able to plot it onto his paper chart, dozens of which he carried in shelves on the bridge. And then a little bit later, the first electronic navigation charts were developed. Initially these were just digitized versions of paper charts, but later they became much more technical and had much more data behind them. We had the vector charts, which we now all use. And then in the 2000s, we had the Automatic Identification System, AIS. This was automatic transmission between ship and ship, or ship and shore, of digital data concerning each vessel which was so equipped. And this was a major enabling factor for e-navigation, because at last the master on board had a clear picture on his electronic chart of not only his own vessel but all the other vessels around him. He knew the name of the nearest vessel. He knew the course it was taking, its speed, its rate of turn. He had its radio call sign, so he could call it up if necessary, if he wished to communicate on VHF. And at the same time, the VTS operator ashore, he could see all the ships that were entering his port, he could see their name, and he was able to then issue advice to them on the best way for them to enter his port. So that was really the means by which not only was, perhaps we could call it the start of e-navigation, e-navigation Mark I perhaps, GPS, electronic charts and AIS, but it also enabled the shore services to provide much better service to the mariner. We also saw at that time that we had things called AISAs for navigation. These could be placed on buoys and beacons and would broadcast a digital message automatically to the ship indicating the name of that buoy, its position, in any time of day and under any weather conditions. A real breakthrough. Now, I'm going to describe the beginning of thinking about e-navigation by referring to a gentleman called Brian Wadsworth from the UK Department of Transport, but I don't know whether he was the first one or not, but certainly he was one of the early gentlemen to talk about this. And he said that this is e-navigation, and it's primarily the transfer of information from one point to another, between ships or between ship and shore. And why would we want it? For this reason. And I've highlighted those words there, reducing costs, because my own personal view, and I'm going to make some personal comments here, not necessarily of which you should ascribe to Ayala, but just my own thoughts. I think that one of the great benefits of e-navigation will not just be improved safety and security, but it will be an increase in efficiency and a reduction in transport costs. And he also said that how this would be done. And again, I've highlighted some words. They're shore-based intervention capability. I do that because I think that vessel traffic services will become increasingly important in the future in congested waters like the North Sea and perhaps the Malacca Strait. Later that year, in the IMO, a number of nations submitted a paper in which they raised the same points. The need for efficient electronic positioning, the need for electronic charts, and the need for information exchange ship-shore and ship-ship. My organisation, Ayala, started its work in September 2006 with the first meeting of our e-navigation committee. It's held its 14th meeting just towards the end of last year, and it will be continuing with those meetings later this year. We've provided a lot of the technical input to help IMO with its work. If we look at a picture of a conventional, or perhaps an older ship's bridge, and that's not terribly clear, but I think you can see that there are pieces of discrete equipment, analog equipment, both at sort of waist height and also up in the air above the bridge windows. In that kind of ship's bridge, in general, none of that equipment was very much communicating with the other. There were individual sources of information. And I believe that the people who were initiating the concept of e-navigation probably had in mind something more related to what is done in the air. This is a modern A380 cockpit, and I think you can see there the sort of thing that the people who started talking about e-navigation back in 2005 were thinking of. They were envisaging electronic display. They were seeing that the position of the aircraft or the vessel was available on an electronic chart display, and in this case we can see that it's duplicated. Now, there are ships like that today, and this is a picture of a bridge of a modern ferry, and I think it looks very similar to the aircraft case. The designers of this bridge have obviously taken account of human factors. There's a display showing the position of your own ship and other vessels on an electronic chart, and it's duplicated. We've got radar, we've got electronic chart, we have AIS, we have communication systems. I think this is perhaps where we're going with e-navigation as far as the navigating officer is concerned. Similarly, on shore, vessel traffic services can now take advantage of the developments which we're seeing in e-navigation, and here similar pictures, Helsinki Vessel Traffic Service and the Port of London Authority. Again, clear display and electronic communications. Today, work on e-navigation is taking place in three areas. It's taking place within the International Maritime Organization, with national and regional initiatives like this one here, ACCSEAS, and with international organizations like my own and others. I think we're all hopeful that the work in these three areas will gradually coalesce to produce a final e-navigation result, and we're all hoping to work in that direction. In IALA, we're particularly working on harmonization of the results of test beds, in other words, so that we can compare the results of a test bed like this ACCSEAS test bed with other test beds in other parts of the world, and able to draw some conclusions for the future of e-navigation. We're also looking at communications and the structure of where data might be stored and how messages might be formulated, so that we have a harmonized message and data structure. In IMO, within the last few weeks, the leader of the IMO e-navigation correspondence group, which is Norway, has completed its draft Strategic Implementation Plan, or SIP. And I think you have another 2 weeks to make your comments on that. But this sets out the IMO vision for the development of e-navigation. And IMO has used two criteria. First one applies to the ship's bridge, the seamless transfer of data between various items of equipment. So if we think back to that first picture of the older ship's bridge, none of those machines on the bridge there was talking to another one in general, and compare that with the more modern aircraft or more modern ship's bridge, where the interrelated items are communicating with each other. And IMO sees these 5 solutions as vital to its work on e-navigation. And we see the bridge design, which we've already talked about, automatic reporting. I'll briefly talk about that. You know, someone told me, I don't know whether this is true or not, but those of you who are mariners will probably recognize it. This was a third-hand story where the master of an American flagship was approaching Europe, and he had to call at 5 European ports, and he mentioned that he had to provide more than 80 reports. I can see some people nodding, so it's perhaps not unusual. Why couldn't this all be automated, so that the master of the vessel enters the data before he starts his voyage, and then those reports are generated automatically in the version required by the particular port of destination or by the national authorities in the waters in which he is travelling? It could all be done automatically. Tremendous load on the ship's bridge today. And we had a conference in Denmark recently, organised by IALA and the Danish Maritime Authority, and the thing that came out most clearly in the first presentations at that conference just last month was masters talking about the workload of providing vessel reports from ship to shore. I'm just going to mention a couple of national initiatives. In Australia, they've introduced an under-keel clearance management scheme using a web-based system to enable vessels transiting the Torres Strait, the strait between the northern tip of Queensland and Papua New Guinea, an international strait, to enable them to load maximum cargo to go through on the tide. Again, an economic benefit. In Canada, the St. Lawrence Seaway has for some time used the radio channels of the automatic identification system to carry automatic digital messages to enable them to regulate the flow of traffic into locks and through the locks to achieve maximum benefit of cargo transit through the seaway. The US Army Corps of Engineers is looking at a similar kind of AIS messaging, and they have a particular problem with those large barge tows that you've possibly seen travelling on the Mississippi and the other large American rivers. Massive numbers of barges joined together with a pusher at the back, very, very susceptible to cross currents. And the Corps of Engineers, which is responsible for the waterway traffic there, is planning to use a form of e-navigation to try to improve that. Similarly, Korea is becoming one of the leading lights in the development of e-navigation, and they are planning to introduce a smart navigation, their word for e-navigation, and they're particularly concentrating on small craft and fishing and pleasure boats because they see a lot of accidents in Korean waters with those. So it's not just for SOLAS vessels, large cargo vessels, it's for smaller craft as well. And then Finland and Denmark have done similar things. Regional initiatives, ACCSEAS, we have a project also with European support, Mona Lisa, and I'm told now there's a Mona Lisa in ice for the Arctic area. And Korea, Denmark and Sweden have signed a memorandum of understanding just recently with the objective of doing a Mona Lisa type project in Korean waters. And for some time there has been the Far East Radio Navigation Service, which is devoted to ensuring this positioning that was mentioned earlier. The use of Loran Sea, China, Korea, Russia, all cooperating to broadcast supplementary signals in case the GPS signals are disrupted. Work of ER. Well, we've recently agreed a new strategic plan to take us through to 2026. It might seem a funny date, but it's 3 times 4 years and we work in 4-year periods. And we've set a set of priorities for the next 4 years to take us up to 2018. Our e-navigation committee will work in this area, particularly on communications, data modelling and maritime service portfolios. MSPs are the services which would be provided from shore to ship, the sort of things like vessel traffic services and weather and tidal information. And our objective is to try to harmonise those globally to set some recommendations or guidelines which we hope would be adopted worldwide. And our VTS committee will work in these areas. You might not be aware that there's no standardised form of phraseology for VTS communications, so that's a kind of non-electronic task that we're going to take on in the next few years. And ERLANET, this is a system we have where various national authorities can exchange information on the position of vessels derived from AIS. We hope to extend that further. Well, the outcome of e-navigation will be something like this. We hope that there will be reduced workload on the bridge. There must be. That appears to be a primary objective. The dynamic route exchange, which has been proposed by the Mona Lisa project, we hope will lead to not only improved safety, but also fuel and economic savings. And we think that these developments will lead to improved coordination and better efficiency for the whole transport chain. There's just a question. If certain vessels are better equipped, should they receive certain preference on certain routes? I don't know. Probably too early to say, but that might be something in the future. Just a speculation, not a proposal. I think the benefits we're all aware of, safety at sea, protection of the environment. I particularly mentioned the North Sea because that's what we're talking about here today, but also the Arctic is increasingly important for reasons we're all aware of. And of course it must be ultimately for the total transport chain. I think the challenges for us are harmonisation. You know, we're carrying cell phones at the moment and we do all sorts of wonderful things on them, but if there weren't some kind of standards for the radio frequencies and the way the messages are put together, none of them would work. We wouldn't be able to talk to each other. And one of the things that I think we need to do, all of us who are working in navigation, is agree on some minimum technical standards for communications, for data messaging, for data storage. And that's one of the things that my organisation is particularly keen to do. It must be, I think, necessary that we take the work of projects like ACCSEAS and apply it so that we succeed in our ultimate objective, which will be the safety and efficiency of navigation. And if we can do that, I think we can say that we've succeeded. Thank you very much, Chairman.
to talk to you about the human interface, because you gave the example of the A380 cockpit, which is a highly advanced cockpit, and you gave the example of a more advanced maritime platform bridge. But the people who operate those systems are very different people.
Yes.
The maritime world is much, much more disparate. The levels of education and training are very, very different. So what's the thinking of IALA on the human interface aspects of working with these very advanced technologies, please?
That's a difficult one. Yes, I think I would perhaps answer in more general terms, Nick, rather than specifically. I think we know that the aviation world really developed after World War II specifically, and there was a chance to set particular standards. In the aviation world, it's accepted that the advice from the ground is a command almost that one must obey. The maritime world is different. We've had the concept of the safety at seas since I think the 17th century or earlier. The freedom of the seas, I'm sorry. And that continues today with conventions like UNCLOS and so forth. So the mariner must be free to be able to make some of his own decisions, chooses what he's going to do. But I think we'll have to see, to come back to your question, that we'll probably see a new type of mariner coming through gradually. We'll see. I'm told that ships' bridges change every 15 years. A ship is built and has a life of about 30 years, and the bridge is replaced at 15 years. Whether that's true or not, but I was told that by a bridge manufacturer, so I guess it's probably true. So this means that some mariners will have to deal with older equipment for quite a long time. But I hope that we'll see a younger, newer breed of mariner coming up, someone who's familiar with using a cell phone and a computer. And there will have to also be probably training. There's been quite a lot of discussion about this, I think, in IMO and other fora. The way that the design of the bridge should be human-centered design. It should be more intuitive. Few of us are taught how to use a computer, and perhaps that kind of thinking should be applied to the ship's bridge.
Thank you very much. Thank you very much indeed, Mike. And I have a question over there in the corner, please.
Yes, Jon Hervik from the Norwegian Coast Administration. You make a lot of similarities between the aviation industry and the maritime industry, and I agree with you. There is something to learn, and I think trust is one of those. We have Ryanair flying from Norway to Stansted, London. We trust that the authorities hand over the information properly, in a safe way. And do you believe that we can learn something from that trust in the maritime industry? If we learn to trust each other, we can also be able to exchange information in a broader way. Thank you.
Yes, thank you. I think that's also a good question. Perhaps I could just answer it with one example. If we think about this vessel that had to make all these vessel reports to individual ports, why could he not make it once when he entered the European area, for example, and then the information be shared nationally? It's not done yet, I believe. But that would be an example of using trust to make the mariner's job easier.
I have a question. Question here at the front.
Jennifer Tobin is my name, and my interest is in the safety of life at sea and the quality of life for merchant seamen. And the query I have is, how long do you think it will be before commercial shipping companies are prepared to take a dive and get going into all this area, being aware they're driven almost exclusively by the commercial benefit of income?
Well, I think that's why I emphasise my personal view that e-navigation is going to be of commercial benefit to shipping. So I think that when shipping corporations see the benefits that e-navigation can provide them, for example, fuel savings or more efficient routes, I think we'll see shipping companies taking that. But they do, I think, as you're hinting, they do move slowly, so it will not happen very quickly, but we have to be patient, I think.
Mike, thank you very much indeed for answering those questions. We'll just follow your set up. That was excellent. Thank you very much indeed. The three things come out for me there, ladies and gentlemen. First of all, this human interface issue, which I think will be really, really important, and I think we're going to be training very different kinds of mariners over the next few decades. The second thing is the comms and the data transfer infrastructure that's needed to support the sorts of technologies that we aspire to at sea. You simply can't afford that at the moment. The bandwidth isn't there. There's never enough bandwidth at sea. So what have we got to do with comms infrastructure to achieve this? And I thought the other really interesting point was this issue of intervention from shore authorities. Now, most mariners will take a run for the woodworks at that point because they are independently in command of their platforms. So there's a massive cultural change to go on in here as well. So it's not just about the technology, it's about the training, the development of people and the culture that underpins it. So just file that one away.